In this video, we're going to concentrate on the intersection of segments that occurs inside the circle. So anytime your intersection is inside the circle, your relationship is part times part of one segment equals part times part of the other segment. So there are 8 problems that have an inside intersection. The first one is number 3. These two chords intersect inside the circle. The first thing you really want to pay attention to is where the numbers go. So sometimes it's a little hard, like with the number 10, to see which part it goes to. But when you look at the 15, it obviously has to go with this part, so the 10 is going with the part of the segment right here. So this chord, the parts we're looking at are X and 15. So when we look at our part times part relationship for that chord, it's going to be X times 15. For the other chord, the parts are the 18 and the 10. So you're going to have 18 times 10 on the other segment. So X times 15 is 15X. 18 times 10 is 180. And so when we divide both sides by 15, we get X equals 12. Now that's all the problem's asking for, is the value of X, but remember it could also ask you for the lengths of the chords. Remember, even though you're doing a part times part relationship to solve, if you were asked for the length of the chord, you would add the parts together. 18 plus 10 is 28 for this length. 12 plus 15 is 27 for the length of that chord. The next problem that has an inside intersection is number 9. So these chords intersect inside the circle. So again, we have a part times part relationship. So for this chord, the parts are 4x plus 2 and 8. So since one of the parts is a binomial, remember to put the binomial in parentheses. So when you multiply it by the 8, it reminds you to distribute in that multiplication. The parts of the other chord are the 9 and the 4x, so you would have 9 times 4x as your part times part on the other side. So 8 times 4x is 32x, 8 times 2 is 16. On the other side, 9 times 4x is 36x. We call this VOBs, variables on both sides. So to get our variable on the same side, I'll subtract the 32x from each side. So now I'm left with 16 equals 4x. Undoing multiplication by dividing both sides by 4 gives me x equals 4. That's all the problem asked for, but again, you could be asked for the length of the chords. So you would put the value of x in. 4 times 4 is 16. Here, 4 times 4 is 16 plus 2 is 18. So the length of this chord would be 18 plus 8, which is 26. The length of this chord would be the 9 plus 16, which is 25. The next problem that has an inside intersection is number 10. These chords intersect inside the circle. So the parts of this chord are 9 and x. So we have not part times part would be 9 times x. On the other segment, the chord's parts are 12 and 15. So you'd have part times part being 12 times 15. So when we multiply the 9 times x, obviously we get a 9x. 12 times 15 is 180. So when we divide both sides by 9, we get x equals 20. So that's all that we're asked for here. But again, if we were asked for the length of the chord, we'd add the 9 and the 20 here to get 29. Add the 12 and the 15 here to get 27. The next inside intersection that we have is on number 14. These two chords intersect inside the circle. So again, we have a part times part relationship. So the parts of this chord are 16 and 7. And the parts of this chord are x and 4. So x times 4. 16 times 7 is 112. X times 4 is 4x. So we would divide both sides by 4 to get our x value to be 28. Again, if we were asked for the lengths of the chords, we would add 28 and 4 to get 32 for that chord, and 16 plus 7 to get 23 for that chord. The next problem with an inside intersection is number 15. We have two chords intersecting inside the circle. So when we look at the parts here, be really careful with the 17 and 24 here. Of course, the 24 can't go with that part. That would be the 17 with that part, 24 with that part, 12 with that one, x with that one. So this chord, the parts are x and 24. For this chord, the parts are 17 and 12. So 17 times 12. So on the left side, of course, x times 24 is 24x. On the right side, 17 times 12 is 204. So when we divide both sides by 24, even though we get a decimal, it terminates, so it's fine to write your x value as 8.5. If it doesn't terminate, make sure that you hit Math Enter to get that as a fraction. So if your x is 8.5, then the length of this chord would be 8.5 plus 24, which would be 32.5. And the length of this chord would be 17 plus 12, which is 29 units, whatever the units are. The next inside intersection is number 16. These two chords intersect inside the circle. So again, we have a part times part relationship. The parts of VA are 8 and 3. So part times part. The parts of RB are x and 6. So x times 6. 8 times 3 is 24. X times 6 is 6x. When we divide both sides by 6, we get x equals 4. Again, the length of BR would be 6 plus 4, which is 10. The length of VA would be 8 plus 3, which is 11. But all it asked us to do was find the value of x. The next inside intersection is with number 19. We have the two chords intersecting inside the circle. So part times part of Km, the parts are x and 3x. So we'd have x times 3x. For Ln, the parts are 6 and 8, so 6 times 8. Here, the algebra you have to remember is when you multiply monomials, your coefficients multiply. So this would be a 1x times a 3x. 1 times 3 is 3. When you multiply numbers with the same base, like these both have a base of x, you add the exponents. And the exponents are understood ones on those x's, so that would become x to the second when you add those exponents. And then on the right side, 6 times 8 is 48. Before you can solve for x, you need to get x squared by itself, so getting rid of the 3 means you're undoing multiplication by dividing both sides by 3. So you get x squared equals 16. Then you can undo the squaring of x by taking the square root. So you do that to both sides to keep it balanced, and you get x equals 4. Again, if you were asked for the length of the segments, this part is your x, which is 4. This part is 3 times 4, which is 12. So the length of Km would be 4 plus 12, which is 16. The length of Ln would be 6 plus 8, which is 14. And then the last inside intersection that we have is on number 23. We have chords QT and PS intersecting inside the circle. So part times part. Here, when we look at the parts, we're given 4 for this length. Over here, we have tick marks showing they're congruent, so the part here would also be 4. So you'd have 4 times 4 for part times part of PS, and the parts here are 2 and x plus 3. So when you do part times part, again, that binomial needs to go in parentheses to remind you to distribute the 2. So 4 times 4 is 16. 2 times x is 2x. 2 times 3 is 6. Solving that two-step equation, you would subtract 6 from both sides and then divide both sides by 2. So you get x equals 5. Again, if we were asked for the lengths of the chords, we'd have 4 plus 4, which is 8. 2 plus, we'd have 5 plus 3, which is 8. So 2 plus 8, which is 10. So those are all the problems that have the inside intersection and therefore have the part times part relationship.